All right, hello everyone. Sorry for running late. We're going to start in a minute. Let's see, let me share my screen first. All right, hopefully you can see the screen I'm sharing. So today we're going to begin with looking at some graphs and some applications with sine and cosine functions and try to actually come up with the formula. I think you're going to find the process a little bit easier than what we did in the past, which is involving taking the function and graphing the function. Which everything's fine. Okay. All right. So I have quite a few problems that I posted here. So don't worry about trying to copy the actual problems down because it might take a while. So let's just work with what we have here. So here's the graph of this function is y equals -4 cosine pi x. It's already given. So we actually don't need to find the sinusoidal function in the form of a cosine bx minus c plus d. And if we do, we can just try to match it. So we got y equals -4 cosine pi x. And if we want to match in the correct form, so y equals a cosine bx minus c plus d, we're just going to look for the part, the corresponding part. So we know that by comparing the given function and the standard function, we know that a is equivalent to -4, and the b is equivalent to pi, and the c, there's no c in this part, so c equals 0. And the d, there's nothing at the end, so d equals 0. Right? So that's easy. But what if we don't have the function given? Suppose we wasn't given this. Can we come up with a formula? Right? So in order to do that, so to find the sinusoidal function, we usually need a few things. We need to know the amplitude from the graph. I just call that A. We also need to know the period from the graph. Let's call that T. And from the period, we can actually come up with a B value for the function. And then the next thing we need to know from the graph is we need to know the midline. That's called M. And we also need to know the shift left or right. So the phase shift. Phi. Because the phase shift is going to tell us what the C is. So phi equals C over B. In another way, personally, I don't really try to remember the formula in this form. What I try to remember is the function y equals a cosine parentheses b parentheses x minus phi plus c. So the phase shift is here, but if we distribute the b into there, we get c. So those are the important things that we should be looking for based on the graph. And another thing we need to be careful about, also note the starting position and direction. Let me put a quotation around starting because it's a periodic function, so it doesn't really have a starting point. But we could say, okay, I'm going to start with this point and try to graph it on both sides of that point. So what I meant by that is, let me just give myself a little bit more space here. So just to recall that for sine function, it goes from the origin, go up and down on both sides. Now, I just want to point out that if we were to draw the midline using the green line, and we're going to draw the maximum and the minimum line using the dotted green line. So this point at the origin, we can think about it's a starting position. It starts on the midline, because that's the midline, and then it's going to go up when it goes right. So that's sort of like the signature for the sine wave. If you pick a point and it's a starting point on the midline, and it's going to go up as it moves to the right, so that will be the sine. And the cosine function, you remember that it's starting at the highest point and then coming down, goes back up. So we can think about, this is still my midline, but at the point I pick, this point on the y-axis, it does not begin with the midline, it begins with the highest point and it's going downwards. So if it's starting with the highest point and it's going downwards as it moves to the right, that's cosine. And suppose I have another graph that looks like this. It's going down, going up, and left is going up. So it starts at the midline. So suppose this is my starting point. It's starting on the midline, but it's actually, instead of going up like sine, it's actually going downwards first as it moves to the right. So this will be negative sine. So if you pick a point, say, okay, my function starts here and it's going downwards, so that will be negative sine. And what if we have a function, let's see, when we pick the starting point, it actually picks, is the lowest point we begin with, and it's going to go up, coming down, that side is going up, coming down. If you have something like this, the midline is still here, but the point I picked does not begin with the midline, it begins with the lowest point and it's going to go up. So from the lowest point going up, that's going to be a negative cosine function. So those are the 4 different cases that I always look at when I look at a sinusoidal function, when I want to decide whether I'm going to go with positive sine, positive cosine, or negative sine, negative cosine. I pick a point that I think is important as the starting point, and then I just see where it is and which direction does it go. So that's going to help me deciding the positive or negative sign in front of the sine and cosine function. Right? So let's practice this with a given function. So this given function is giving me negative cosine. Let's see if we can write a different formula, but for the same graph. All right, let me take this graph. I'm going to copy it here again. So I have the same function, but this time I'm not going to use negative full cosine. I'm going to use the maybe positive sine function. So the first thing before I do anything is I need to find out the amplitude. So from the graph, this is my midline, the line in the middle. So that's the midline. And that's the origin. So midline, which is going to be y equals 0. So that's a 0. And from the midline to the highest point, so that's the amplitude. Amplitude is from y equals 0 to y equals 4. So the a equals 4. And then I'm going to find the period. The period you can pick from the lowest to lowest or highest to highest or somewhere in the middle until it repeats. It's up to you. So it's probably easier to pick maybe the lowest point. So that's the first lowest point. This is the second lowest point. So the distance between them, it's going to be from 0, because that's a y-axis, x equals 0, to x equals 2 here. So the period is 2. That means I can find the b value. Remember that period equals 2 pi over absolute value of b. That means b is equal to 2 pi over p. and the period is 2 we said here. So b equals 2 pi divided by 2, which is pi. So the b value is pi in this case. So now I found the midline amplitude and the b value. That's good. I just need to know the phase shift. Phi. Well, it depends. I want to begin with sine. So remember, sine is I'm looking for the point on the midline and going up. So that's this point. That's a point on that midline and it's going upwards. So that's the point I'm considered the starting point. And where is it? It's at positive 1/2. It's not at origin because it's being shifted to the right to 1/2. So phi equals 1/2 to the right. If I say, okay, can I use this point instead? This is about 5.5, 2.5. That's totally fine. You can use this x equals 2.5 and then use that point as the phase shift. That's okay. So there's a lot of different starting points you pick, so the phase shift will be different. But I'm going to use the first point near the origin. So now I can write down the function with what I have. So the formula I use, like I said earlier, it's going to be this one right here with the factor form inside the cosine, and then I'm going to distribute the b. So I get y equals a, which is positive 4 sine. I'm using a sine function here because I picked the midpoint and then it's on the midline, it's going up. Sorry, the starting point. So 4 sine, parentheses, b is pi, parentheses, x minus 1/2 because we're shifting to the right by half. And there's no midline, so plus 0. So that's using positive sign. And if we simplify this by distributing the pi in the parentheses, so we get y equals 4 sine pi x minus pi over 2. So that will be the correct function, just like the given one, -4 cosine pi x. It's the same. They give you the same graph, just different function we choose. So that's use positive sign. Now, what if I use negative sign instead of positive sign? If I use negative sign, the amplitude doesn't change, the period doesn't change, the b value doesn't change, the midline is still the same because the graph doesn't go anywhere. So let me write it down. So using negative sign, so we get amplitude is still 4, p is 2, and the b value is going to be pi, doesn't change, and the midline is going to be 0. But what about phase shift? Well, if I'm looking at a negative sine function, I'm looking at the point on the midline and it's going downwards. So that's this point. That's the point on the midline and it's pointing downwards. So that's my starting point. So I should consider that the graph has been shifted to the right by 1.5. So that's a 1.5, so that's a 3/2. So the function is going to be y equals, but this is a negative sign, so the negative amplitude is 4 sine, negative sign, and then we have pi parentheses x minus 3/2 parentheses, close parentheses again, and then midline is 0. So if we rewrite this, that's going to give us -4 sine pi x minus 3 pi over 2. So again, this is the correct function. It's just using a negative sign instead of a positive sign. All right, I'm almost done here. Let's practice one more time. So what if we use positive cosine? So using positive cosine, again, the basic Parameters are the same, so A is still 4, the amplitude doesn't change. The period is still 2, the B value is still pi, the midline is still going to be 0. But what's changing here is a phase shift. So we have to be careful if we pick a positive cosine function. The positive cosine function always starting with the highest point and going downwards. So if I pick the highest point, which is here, 1, 4, and it's going downwards, so that will be my starting point. It used to be on the y-axis, now it's being shifted to x equals 1. So the phase shift is equal to 1 to the right. So now we can write down the function, which is y equals, now it's positive cosine, so that's the full cosine parentheses, b is 2 pi, x minus the phase shift 1. So we get full cosine pi x minus pi in the parentheses. So that's the positive cosine function, which is different from negative cosine function, which doesn't have a shift, but if we pick a positive cosine function, we have a shift. So I hope that gives you enough sort of background information about how you should be solving this problem if you were to do it on your own. Any questions on what I did over this problem? So if a question just say write a sinusoidal function, you can use any of the full trig functions, positive or negative sine and cosine. But if it specifically says using, sine x, then you need to keep it positive. If it says cosine x, you need to use positive cosine. If it says negative, then you just use negative trig function. All right, so I just want to point out one more time that, again, it depends on which point you choose as a starting point. You're going to end up with a different function. Even if you use positive sine as a function, again, you can pick different starting points because the function is periodic. So the one point you pick, that's going to repeat after 1 period, after 2 periods, always repeating. All right, so let's look at another example. So this example I have, it says the height of the tide in a small beach town is measured along a seawall. Water level oscillates between 7 feet at low tide and 15 feet at high tide. On a particular day, low tide occurs at 6 a.m. and high tide occurs at noon. Approximately every 12 hours, the cycle repeats. It says find the equation to model the water level. And for any problem like this that oscillates or periodic, it's always good to begin with a quick sketch. Just graph a few important points. So I'm going to try to do it here. So what do we know here? We know that the low tide is going to be 7 feet. The high tide is going to be 15. So that's the lowest and the highest value of the water level. And then it says a low tide occurs at 6 a.m. So let's see, this is like 12 a.m. midnight. And then 6 a.m. is here. And that's going to corresponding to a low tide. So that has a height of 7. And then 12 corresponding to a high tide. So let's see, this is 12 p.m. at noon. And we end up with the highest value. And they already tell you that the cycle repeats every 12 hours. So from 6 a.m. to 12 p.m., that's 6 hours. So that means in the next 6 hours, it's going to fall back to the, so at 6 p.m., it's going to fall back to the lowest level. So that's from lowest to lowest, that's already 1 period. And then for the next 6 hours, it's probably going to go back to the, oops, wait a minute. So that's going to go back to the highs again, so that repeats. So from here, you can just try to draw a graph, make it look like a sine. So that's what I meant by a quick sketch. And how do we write down the function, right? We can do that if we have all the different pieces. So first of all, we need to know the amplitude. We need to know the period. We need to know the b value from the period. And then we also need to know the midline. And we need to know the phase shift, depends on which function we choose. Let's suppose we pick the function, let's say cosine, positive cosine. So how do we find the amplitude? Now, the amplitude is not from the lowest to highest, it's actually from the midline to the highest or to the lowest. So we need to know where the middle is. So the midline should be halfway between 15 and a 7. So that should be the midline. So that's just going to be the average of, the middle is the average of two numbers. So the midline is going to be 15 plus 7 over 2. So that's 22 over 2, that's 11. Or you can just count. 15 minus 7 equals 8. 8 divided by 2 is 4. 4 plus 7 is 11. So that's a midline at 11. So from 11 to the highest, that's my amplitude. So that's 15 minus 11 equals 4. What about the period? Now it kind of tell you that every 12 hours, the cycle repeats, right? So 12 is the period. You can also look at the sketch, make sure it's correct, from 6 a.m. to 6 p.m. That's the lowest to lowest. So that's a full period, 12 hours. And then we can find B because P equals 2 pi over B. B is 2 pi over 12 P. So that's going to be pi over 6. What about phase shift? Well, phase shift, we're going to use positive cosine. So positive cosine always start with the highest value, and it's going to go down as we move towards the right. And that exact point is actually this point right here at noon. So that's the highest point, and it's going to go down from there. So that's my starting point, and it's being shifted from the y-axis to 12 p.m. So that's going to be 12 units to the right. Any questions about finding those values? So now we have all of them we can put into the form. So the form I use, again, let me just write it down. So y equals a cosine parentheses b parentheses x minus b plus t, the midline, or m. So now let's plug in what we know. We know that a is 4, and the cosine in the parentheses, we have b, which is pi over 6, x minus b, so x minus 12, plus the midline, which is going to be 11. So this is my function. If you want, we can simplify the parentheses part. So that's a full cosine pi over 6x minus pi over 6 times 12. That's a 2 pi plus 11. So both are correct. Now, I just want to point out one thing here is you probably wonder, okay, when I write down the a cosine, do I need to make sure it's -4 or +4? Now, you don't even have to think about that because we find the phase shift by deciding which function we use first. So we already decided we're going to use positive cosine. So it's just going to be full cosine. If we decided to use a negative cosine, then we just put a negative in front of the full. Any questions on this example? Okay. All right, so here's one more example we can practice. It says the daily temperature in the month of March of a certain city varies from a low of 24 degrees to a high of 40 degrees. And we're going to find a sinusoidal function to model the daily temperature and sketch the graph. And it says approximate the time when the temperature reaches the freezing point, 32 degrees. But it also says let t equals 0 corresponding to noon. So let's sketch a graph first. We know that the lowest is going to be 24. So let's see, this is lowest 24 degrees. And the highest is going to be 40. So this is the highest, 40. All right. And then it didn't tell us when the lowest happened, when the highest happened, right? So here we just have to use what we know. I mean, not accurate, but what we commonly know is that in the middle of the night is cold. During the day, around noontime or maybe early afternoon, it's going to be really hot, right? So I'm going to simplify this just saying that the highest temperature is at noon. And the lowest temperature is going to be at midnight. Because that's going to save us some trouble here. So let's label some values. So let's see, this is midnight, the origin, and 12 hours later at noon. So at midnight, it's going to have the lowest temperature, 24. At noon, it's going to have the highest temperature, 40. And obviously, when it falls back to midnight again, the temperature is going to go to the lowest. And that's the full period. It's 1 day, 24 hours. So we can just quickly graph it. So that's a full period. Now note that it says t equals 0 corresponding to noon. So this is t equals 0. And midnight, from noon to midnight is 12 hours. So t equals 12. And the previous midnight is t equals -12. And from here, we can write down the function with some important parameters that we have to find. So we know that the lowest 24, highest 40. So that means the midline is going to be the average of those two numbers. So amplitude, period, p-value, midline, phase shift. So let's say midline is going to be the average between 40 and 24 because it's a point in the middle. So that's going to be 40 plus 24 over 2. That's 64 over 2. It's going to be 32 degrees. And the amplitude is going to be from the highest to the midline. So that's going to be from 40 to 32. It's going to be 8 degrees. Now, what about the period? Now, we already know the temperature varies every day. So from midnight to the next midnight, it varies. So that's a cycle. So period is equal to 24 hours. And a B is going to be 2 pi divided by 24. So that's going to be pi over 12. That's the B value we need for the formula. Now, what about phase shift? Again, it depends on which function we choose, right? You can be clever because you can just say, okay, I'm going to use positive sine, that's fine. Or use positive cosine, that's also okay. Or you can use negative sine or negative cosine. Now, if I'm being a little bit lazy, I'm looking at the graph. I'm already starting with the lowest point on the y-axis going up. So it looks like I'm already starting with the lowest point on the y-axis, which means if I look at it as the lowest point to begin with, that's the negative cosine. So if I choose to use negative cosine, there wouldn't be any shift because I'm starting right on the y-axis, no shift. No shift if choosing negative cosine. If I choose positive cosine, oh, you know what? I made a mistake. Jesus, I forgot the time equals 0. Why do I put it there? I'm so sorry. I should draw the axis here because that's t equals 0. Let me take back what I said. So if I choose negative cosine, that's actually a shift because it's away from t equals 0 to the left by 12 units. You know what? Let's just use negative cosine, whatever. So the shift, because t equals 0 is right at noon, if we choose as negative cosine, starting point is to the left side of that axis, the y-axis is by 12 units. So that's 12 units to the left. Sorry about that. If we choose positive cosine, that wouldn't be any shift because the highest point is right at t equals 0. Okay. Well, let me finish this negative cosine, then maybe I'll write the function for positive cosine. So now I have all the values I can put into the function. So y equals 8, which is 8, but it's negative cosine, so negative 8 cosine, parentheses b, which is pi over 12. And then it's going to be t instead of x, but it doesn't make a difference. Minus, but it's a 12 units to the left, so it's t plus 12, minus t minus negative 12. You can think it in that way. And the midline is going to be 32. So that's the function. So that's going to be negative 8 cosine pi over 12t plus pi over 12 times 12, that's a pi, plus 32. So that's using negative cosine. And then supposedly we use positive cosine. So the phi it's going to be no shift because the starting point is the highest and it's also on the y-axis, so no shift. So that's going to be y equals, still going to be amplitude 8, but it's going to be positive cosine, parentheses, pi over 12. That's a b value. And then t, but there's no shift, so we don't subtract or add any number to t. And then plus 32. So that's a little bit easier. Sorry for the confusion earlier. Does that make sense? Any questions on this? Okay. All right, so let's see. Now the next thing I have is going to be a, look at this. The next thing is, I'm looking at my notes, I have all right. The next thing is going to be simple harmonic motion. Now you probably already seen it in the past. A harmonic motion basically is a periodic motion that, for example, when you have a pendulum, you have an object tied to a piece of string and you hold it in a position, then you let it go, it's just going to go back and forth, back and forth. You can think about the height of this object relative to either the ceiling or some ground. That's the height. It's going to be a sine function if we want to plot the height. So that's a harmonic motion. It could also be a spring. For example, let's just say you have a spring attached, maybe a project attached to the end, the other end of the spring is attached to the wall. Let's say, suppose you either compress it or stretch it to a certain point. So let's say you stretch it to here. Oops, let me redraw this. So suppose you take this spring and then you stretch it. So it begins here, and then you let it go. It's just going to go back here and then back and back and forth to the position of the object of the end of the spring. That's going to be a harmonic motion. It's going to be periodic. So that's just what harmonic motion really refers to. It could also be gravitational force. For example, the reason that the Earth is moving around the sun is due to gravitational force, and it's moving periodic as it moves away, and then the force is pulling it back. As it's getting really close, it's kind of repelling it. So it's always have this like close, far away motion. All right. So let's continue with the spring example. Just going to draw the diagram again. Suppose we have this spring, and suppose we did not stretch it, just leave it the way it is. And at this, see, this is t equals 0, and it's not moving anywhere. So the displacement d equals 0, right? But suppose we actually stretch it. So if we didn't stop from this equilibrium state, suppose we stretch it. And in the stretch mode at t equals 0, the displacement, it's going to be the distance from the rest to whatever we stretch it to. So that's the displacement. D is not equal to 0. When it's stretched. When it's compressed, is the same. And the general formula for simple harmonic motion, the general formula for simple harmonic motion, it's going to be the displacement from the resting position is equal to a cosine omega t. It's actually, it looks like a W, it's omega, but you can think about it's W, it doesn't matter. Or a sine omega t. So that's the general formula. And in this formula, A here, so the absolute value of A is the amplitude. It's also called the maximum displacement of an object. So that's A. And it's often equal to the initial displacement. And then the B, the omega is kind of like the B we had. So the period, it used to be 2 pi over B. Now it's just 2 pi over omega. So that's the period. There's one more term we haven't talked about, but you're probably seeing it in a physics class. It's frequency. F is equal to 1 over the period is equal to, if you flip the fractions, that's going to be omega over 2 pi. So the frequency is going to tell us the number of cycles per unit time. So if you think about P as a period, if 1 is a unit time, so in 1 unit time, how many periods do we have? So 1 divided by the period. So you get how many periods, which is the number of cycles. So that's frequency. And let me give you examples. So given y equals 6 cosine pi over 12t, and we're going to find the maximum displacement. Well, the maximum displacement really just coming from the amplitude, and which is given by the a value, the coefficient of cosine, in this case is 6. We don't need to take the absolute value, it's already positive, so that's just going to be 6. So let me rewrite it. D max is going to equal to 6. And if we want to find the period, we have the omega, which is pi over 12, or b equals pi over 12, and then the period is going to be 2 pi divided by omega, which is 2 pi divided by pi over 12. So 2 pi times 12 over pi, so that's going to be 24. That's the period. And if we want to find the frequency, so f is equal to 1 over p. It's also equal to omega over 2 pi, depends on which one you use. So you could write the 1 over the period. Remember, period is equal to 24. So it's going to be 1 over 24. So that's the frequency. It only finishes 1/24th of a cycle in 1 unit time. Or you can find through omega over 2 pi. So that's going to be pi over 12 divided by 2 pi. That's going to be pi over 12 times 1 over 2 pi. Again, it's just end up with 1 over 24 again. So 2 different ways to get the frequency. Any questions about maximum displacement or the period or frequency? I mean, we have seen the period before and we've seen amplitude before. Now we just use a different term. It's called maximum displacement. Now the next thing, any questions on this? So I'm just creating more space for me. So the next thing is called damped harmonic motion. So instead of the simple harmonic motion means it's always oscillating back and forth. There's no change in the amplitude. Now a damped harmonic motion, it's going to have amplitude decreasing due to external forcing. For example, let's see. For example, when we earlier we had that example with the spring and the object attached to it. So when we have it stretched and we let it go, it's going to go back and then go forward and then go back. When the spring is compressed, it's going to go forward. Now, if there's a friction between the object and the ground, and that friction is going to make it difficult for the object to move back and forth. So eventually, the friction is going to cancel some of the forces in the spring. So the object is not going to return to the starting point during the oscillation. So that's called damped harmonic motion. And it has this formula, which is f of t equals a e to the negative ct cosine omega t, or a e to the negative ct sine omega t. So this e to the negative ct, note if c is positive, t is positive, this is really just exponential decay. So this is going to sort of giving that decreasing impact to the amplitude. So in this formula, the A and e to the negative ct together is actually the new amplitude. So a absolute value of a e to the negative ct together is the amplitude of displacement at any time t. But the a alone is the initial displacement, because if t equals 0, e to the negative ct is 1, we just get a. So this is the initial displacement, sort of like the starting displacement. And the omega is the same, but the c here, so the c value in the exponent is the damping factor. If c is really big, then the damping factor is much stronger, so it's kind of like makes the exponential term goes to 0 a lot faster. So that's called damped harmonic motion. Any questions on this? All right, if not, we're going to look at this example below. It says a mass spring system exhibit damped harmonic motion at a frequency of 0.5 cycles per second. So it gives us the frequency. And it has an initial displacement of 10 centimeters and a damping factor of 0.1. Find the equation and the graph. So whatever the displacement is, if we were to graph it, initially it begins at 10. And that displacement over time is going to decrease. So it's not going to, when it goes back up there, it's not going to go that high. It's going to go lower and then lower everywhere. So that's kind of like the graph. And because it begins with the highest point, the highest displacement 10, so we're going to use the cosine in this case. So using positive cosine function. So that's going to be f of t equals a e to the negative ct cosine omega t. And we need to find out a, c, and omega. So let's find each one of them. So a, recall that a, the absolute value of a, just the initial displacement. And we already know initially the displacement is 10. So a equals 10, the initial displacement. And then c is the damping factor, which is also given, 0.1. We don't have to find those. And we need to know the omega, but the omega is not really given. We know the frequency, f equals 0.5. And how do we use this to find the omega? Well, note that frequency is equal to 1 over p, or is equal to omega over 2 pi, because p is 2 pi over omega. So we can use this formula. So frequency equals 0.5, that's equal to omega divided by 2 pi. So we can solve for omega, which is 0.5 times 2 pi. And that's going to be 0.5 times 2 is 1, so that's just equal to pi. So we have a, we have c, we have omega, then we can put into the function. So you get f of t is equal to a, which is 10. And then we have e to the negative, c is 0.1 t, cosine omega is pi, so pi t. Any questions on this? I'm going to be a bit lazy because I'm not going to expect you to graph it by hand, but let me just quickly describe if how you graph by hand. So in this part, this is my amplitude, and it's an exponential decay function. The midline equals 0. So this is the middle. So the midline equals 0. The amplitude is going to follow this exponential decay function. So we can just graph it. Exponential decay function begin with 10. So that's going to look like this. So that's the exponential decay. And that sort of gives us the upper bound, and we need to know the lower bound. So just literally take that curve and reflect it over the midline so that we get this lower piece. And then this cosine pi t, and the period is going to be 2 pi over pi. It's just going to be 2. Let's see, that's a 2, this is a 4, and that's a 0. So 1, 2, 3, 4. 1, 2, 3, 4. And it's cosine, so it's going to begin with the highest point. So it's going to go down to the midline and then go to the lowest point, go back up to the midline, go to the highest point. That's the end of a period. So from highest to highest. And then if we want to graph another period, so again, it's going to go from the highest, going down to the midline, go to the lowest, and go back to the midline, and go to the highest. So that's the second period. And then as we continue the exponential decay function, the amplitude keeps decreasing. So the graph is just going to be smaller and smaller between this minimum and maximum. So that's what the graph looks like. All the amplitude does is just kind of limiting how high and how low the graph could go to. So this is called a damped harmonic motion. It's really just decreasing harmonic motion. Any questions on this example? All right. So the next thing we're going to do, we're going to look at one more example. It says find in the graph a function of the form y equals a e to the negative ct sine omega t. So it's using a sine function. And the models are given information. So we are given that amplitude, the A in the formula is 7, and the C, the damping factor, it's going to be 10, and the P is the period. So it's very similar to what we did. We just need to find out the A, which is given, C is also given, and the omega, which is not given, but we can find it. So from here, we're just going to plug in A, plug in C, and plug in P, but we have to convert P to omega. So y equals A is 7, e to the negative C, 10t, and then sine omega t. We need to find omega. And we know that period equals 2 pi over omega, which is telling us that omega equals 2 pi over p, which is 2 pi over 6. So that's going to be 2 pi times 6 over pi. So that's going to be 12. That's omega. Put it back into the function. So we got y equals 7 e to the negative 10t sine 12t. That's really just about identifying the correct variable parameters and to put it into the function. Any questions? Okay. All right, I have 2 more examples. I'm not sure if I'm going to do all of them. Let me think. Maybe I should do them. Oh, well, let me begin with the first example on this. It says a spring measuring 10 inches in a natural length and is compressed by 5 inches and a release. So here we have a spring. Normally, if it's not compressed, not stressed, it's going to be 10. But now the spring is actually being compressed by 5 inches. So now it actually have 5 inches shorter. So you can think about the displacement. If this is the natural position, now it's being compressed. The displacement is -5. So let me write displacement equals -5 because it's to the left side. And it oscillates every 3 seconds. So that's a period. And its amplitude decreases by 30% every second. So the amplitude here is not a constant. It changes by decreasing by 30% every second. It's a final equation that models the position of the spring t seconds after it's being released. So if we were to graph it, so the spring has a position of a -5, and then it probably returns to the natural position, and it's going to go up 5, but probably doesn't going to reach that high because of the amplitude decreases. So it's going to reach some maximum height, and then it's going to come down, and it's probably not going to reach -5. It's going to reach some lowest point, and then it's going to go up, go down like this. So let's take this one at a time. So the general formula, I'm going to use a cosine here. So that's the f of t equals a e to the -ct cosine omega t. So first of all, we need to know what a is. So a is the initial displacement. And because it begins with the -5, well, the absolute value of a is the initial displacement. But because I begin with the lowest point is going up, so the spring displacement goes from the lowest point, -5, is going to increase towards 0. So I'm actually going to just consider this is the negative cosine function. And I'm just going to say, okay, a is negative, because that's going to resolve both issues with the initial displacement being 5, and then there's a negative cosine function. And the damping factor, we don't know yet, because we don't know what this exponential part is going to be like. But we can find it because it says the amplitude decreases by 30% every second. So since the amplitude decreases by 30% every second, and then we begin with decreasing by 5, now it decreases by 30%. If we begin with the amplitude that's 5, the initial displacement, and it decreases by 30% every second. So the amplitude, we can think about it as 5 times 1 minus 0.3 to the t. T is in seconds. Okay, but that's not the function I'm looking for. I'm looking for a e to the -ct. So we just have to take this and convert it to a e to the -ct. And the a here is just the displacement 5. So that's going to be, I know I said a equals -5, but the negative is referred to the negative cosine. So a is 5 e to the -ct. and that's equal to 5 times 1 minus 0.3 to the t. So we get 5 times 0.7 to the t is equal to 5 times e to the negative ct. And we can drop the 5. We just get 0.7 to the t is equal to e to the negative ct. And from here, we have to solve for c. So we can drop the exponent t because the two bases are the same. So 0.7 must equal to e to the negative c. Now we're going to add natural log to both sides. We get natural log of 0.7 equals natural log e to the negative c, which is negative c. We get c equals negative natural log of 0.7. And if we have a calculator, we get c equals 0.357. So that's the c value. And then we already had the a, which is -5. And the next thing we need to find is omega, because it says it oscillates every 3 seconds. So the period equals 3. So let's see, I'm going to put on the side here. So note, period equals 3. So omega equals 2 pi over period equals 2 pi over 3. So that's omega. And now we can put everything into the formula. So we get f of t equals a, which is -5 cosine, e to the negative c 0.357 to the t. And then we have cosine omega 2 pi over 3t. So that's the function. Now, I just want to clarify that we have a negative here because we choose to have a negative cosine function. We start with the lowest, so that's a negative cosine function. And the 5 is the initial displacement. Right. Any questions on this problem? Okay, it's 7:20. I think I'm going to skip the next problem. Let's take a break. Let's see. How about 5 minutes break? All right, let's take 5 minutes break. We're going to be back here about 7:25. And then we're going to try to talk a little bit more with the next section. We're going to end early today. Don't worry, we're not going to stay here until 8:30. All right, be here 7:25. See you soon. All right, welcome back. Let's continue with our lesson. 7:25. All right, I'm gonna hope to finish around 8. So the next thing I'm going to talk about is going to be to quite a few of you that's review, because I'm sure you all seen it before in maybe algebra 2 class or precalculus class. It's law of sine. And this is specifically useful when we look at non-right triangles. So let me just try to show you where this formula comes from. You probably all know what the formula is, but you probably don't remember where it came from. I just want to explain it quickly. So suppose we have triangle A, B, C, and the corresponding the side opposite from each angle. I'm going to use lowercase a, lowercase b, and a lowercase c. And what I'm going to do is I'm going to draw a height from angle B. So this is the height. And if I'm only going to look at the triangle on the left, that's the right triangle, with the H being the one side and the C being the hypotenuse. So in this right triangle here, we can say that sine of angle A is equal to height over side C, the hypotenuse. Therefore, we can write that the height is equal to C times sine A. And now I'm going to move on to the right triangle on the right here. That's also a right triangle, with the height being one side and the A being the hypotenuse. So I have sine angle C is equal to the height over side A, the hypotenuse A. Height is equal to A times sine C. Now, since from both right triangles, we have the same height, because the height is the same for both right triangles, so we can set them equal. So we get C times sine A is equal to A times sine C. And rewriting it by dividing by A and dividing by C on both sides, we get sine A over the lowercase a, the length A, is equal to sine angle C over the side C. And if we extend it to a different height, and we can end up with sine A over A equals sine C over C equals sine angle B over side B. So that's called the law of sine. And it's very useful if we look at a non-right triangle, if we know an angle, or maybe know two angles, and one side we try to find the other missing sides or missing angle. It's very useful in that sense. So let me give you some examples. The first one we're going to do is solve the following triangle. And this triangle, I'm going to draw a diagram first. So we know that angle A is going to be 50 degrees. Angle C is going to be 30 degrees. And this side opposite from A is 10. So I'm going to say this is a lowercase a equals 10. But this side opposite from angle B, lowercase b, I don't know. And this side opposite from C, lowercase c, I also don't know. So when we solve this triangle, means we're going to find all the missing angles and all the missing sides. It's easy to find the missing angle B. So angle B, mesh of angle B, is equal to, just use the sum of interior angles, since we already know two angles on one side. By the way, this is what we call the angle side. So this is the AAS case, because we know the angles, and we know another angle, and we know the side next to the second angle. Mesh of angle B is equal to 180 degrees minus 50 degrees minus 30 degrees. So that's going to be 100 degrees. That's easy to find. Good. So we got all the angles, but how do we find the missing side B, right? Well, in order to find the missing side B, we're going to need to use the angle B. And we have a side A, we have angle A. So what we're going to do is we're going to use the ratio, the proportion there. So we're going to write sine A over A equals sine B over side B. So that's going to be sine angle A is 50 degrees. So sine 50 over the lowercase a, which is the side opposite from angle A, that's 10, which is equal to sine B, which is we found out to be 100 degrees, divided by side B, which we don't know. That's fine. We got one equation, one unknown. So from here, we can solve for B. First thing I'm going to do is I'm going to cross multiply. So we get B times sine 50 degrees is equal to 10 times sine 100 degrees. And then we'll divide by sine 50. So B equals 10 times sine 100 degrees over sine 50 degrees. We definitely need a calculator for this case, or if we have some kind of spreadsheet of sine of different angles, we can look it up. So put everything into the excuse me, into the calculator. We get B is about 12.9. So using a calculator. And how do we, so now we found B is 12.9. So let me put it here. So this is a 12.9. How do we find the missing side C? We're going to use the same trick. We're going to have to set up a proportion. So you can use sine B or sine A. So I'm going to use sine A over A equals sine C over C, lowercase c. So that's going to be sine 50 degrees over 10 equals sine C, which is going to be sine 30 degrees over lowercase c, we don't know. We can solve for it. And cross multiply again. So C times sine 50 degrees is equal to 10 times sine 30 degrees. And divide by sine 50, so C equals 10 times sine 30 degrees over sine 50 degrees. And put that into the calculator, we should be able to get a number. So again, I'm not going to do that. It's going to leave it there. Does that make sense? So that's how you use law of sine. I'm sure you have seen this in the past. Now, I want to point out add one concept here is to find the area of non-right triangles. So that's a formula which says the area equals 1/2. Now, if you think about it, it's really just, well, let me actually show you where the formula comes from. So suppose I want to find the area of this triangle ABC above. So I know the area equals 1/2 times the base times the height, right? In this particular example, the base, well, I draw the height this way, so the base is B. So that's a 1/2 times B times the height. Now, which one is the height? Which one do I use? You can use either one. You can use C times sine A, or you can A sine C. Both give us a height. So I'm going to use the second one. So the height equals A sine C. So the formula to rewrite it, make it look nice, is just 1/2 AB sine angle C. Now, the angle C is always the angle between the two sides, A and the B. So C here is the angle between the two known sides, A and the B. That's the formula, 1/2 AB sine C. And for this particular example, if I want to find it, and I know A, I already find B, and I know angle C. So the formula for area, well, let me write again, 1/2 AB sine C. So that's going to be 1/2 times A is 10, B is 12.9, and the sine of angle C, which is 30 degrees, is half. So in the end, we have 1/2 times 10 times 12.9 times half again, and simplify to get it as the area. So this is a formula to get the area for non-right triangles if we know two sides and the angle between them. Any questions on this? Okay. All right. All right, let's look at another example. So we just look at the example of angle, side. Now, the second example, the different example I have is a little bit different. So we're going to solve this triangle. We know that the triangle, let's just see the diagram given, again, similar to what we have. We have angle A, this is the B, this is C, this is 35 degrees, this is 8, this is 6. So this triangle, we know one angle, we know two sides. So this is the case of angle, side. And it's always a bad case. So you have to be very careful. So be careful. And I'm going to show you which part you need to be careful about. So let's just say this is what we have. Right? And let's see, we want to, well, we only have one angle, two sides. Perhaps we can use them to figure out another angle. So let's see, we have A, we have the side opposite from A, which is 6. We have 8 as one side, but that's opposite from angle B. We don't know what B is. So lowercase b is 8, but we don't know the angle B. So let's find it first. We begin with sine A over A equals sine angle B over lowercase b. So let's plug in what we know. So sine A is sine 35 degrees over lowercase a, which is 6. That's equals sine B. We don't know what B is, but we know that lowercase b is 8. So it looks like we're good because we have one angle we don't know, B. We can cross multiply, or we can just simply multiply both sides by 8. So we get 8 sine 35 degrees equals 6 times sine B divided by 6. So 8 over 6 sine 35 degrees equals sine B. And we're going to find the inverse sine on both sides. So inverse sine of 8 over 6 is 4 over 3 sine 35 degrees. That's equal to B. Okay, looks like all good, right? So if we put this into the calculator, so we get B is about equal to 49.9. I'm just going to run it to 50 degrees. But is that the correct answer? Well, it could be, right? But we don't know yet. Now, this is where you have to be very careful. We just found out there's a B. We found out B by using inverse sine of whatever that is. And this turns out to be a positive value. It's about 0.67-ish, 0.7. So because this is a positive value, that's about 0.7. So when we put that into the calculator, we only got one value because the calculator by definition only gives us one sign. But if we look at a unit circle, if the ratio is about 0.7, we not only get this angle of 50 degrees-ish, we also get a different angle in the second quadrant that gives us the same sine value, that's a 0.7. So this is the case you have to find both values. So we found one is 50. Now, how do we find the second angle? The second angle is just going to be 180 degrees minus 50. It's going to be 130 degrees. So this is a very important step to do. That's what I meant earlier. You have to be careful. So after you find the correct B by using inverse sine, you have to find a second angle using the angle you found by subtracting it from 180 degrees. So that gives us a second angle. Now, you probably think, okay, it doesn't look like in the diagram, the triangle doesn't look like it's 130 degrees at B. Well, that is true if you just look at the given diagram, but usually the diagram is not accurate because the same measurement, I can draw it this way. So I still have A, which is 35 degrees. Oops, I didn't draw it right there. And this side is 8. Now the 6, the side opposite from A, instead of having it going this way, I'm actually going to kind of make it swing left. So the A equals 6 is actually pointing to the left. And now we have this sort of obtuse triangle. This is the B. So instead of having the side opening up, opening towards the outside, it's actually sort of curving towards the angle A. So that's why we have this B that could be either 50 degrees or 130 degrees. So that's why we have two different diagrams. Now you probably wonder, okay, do I keep both or do I drop one? Now let's see. The only way to tell whether we keep it or drop it is we're going to find the other angle that's missing to see if it's negative or positive, right? So here we found out that we know that A is 35, B is 50. So if I want to find angle C, that's going to be 180 minus 35 degrees minus 50 degrees. So that's going to be 180 minus 85. So that's about 95 degrees. Okay, no problem there. But if the B is 130, so we get C is going to be 180 degrees minus 35 minus 130. That's going to give us about 165, so it's about 15 degrees. Sure, no problem. So in this case, both values are valid for an angle inside a triangle, so that's okay to have. So in this case, we just have two triangles, like I draw earlier. So in this case, on the left, B is 50 degrees. On the right, the B is about, on the right, the B is about 130 degrees. And the C here is going to be 15 degrees. On the left, the C is about 95 degrees. So this is the case we have two cases, two possible triangles from the given information. Now, you only need to worry about this if you have angle side side. If you have angle side, you don't have to worry about it. If you have all three sides given, side, you don't have to worry about this. This is the only case you have the two different triangles. All right, so now we found out that all the angles, we just need to find the missing side C. So we're going to have to use law of sine again. So to find side C, so we're going to use law of sine. So we can use sine A over A equals sine C over C. For each one of them, for the triangle on the left, we have sine A, so sine 35 degrees over A. Side A, remember, is 6. That's equal to sine C. C is 95 degrees over side C. We don't know, but we can solve for it. So cross multiply. And the solve for C. So C equals 6 sine 95 degrees C times sine 35 degrees equals that, and C equals 6 sine 95 degrees over sine 35 degrees. And in this case, C gives us 10.4. And we're going to do the same thing for the second triangle. So we get sine 35 degrees over 6 equals sine, angle C is 15 here, 15 degrees divided by C. And if we cross multiply again, we get C equals 2.7. So we just have two triangles. Any questions on this? Now, I want to give you more examples just to show you what are other cases we could have if we only have angle side. All right. So the next example I have is, so again, we're given that in a triangle, we're given C, angle C is equal to 85 degrees. And the side opposite from this angle, lowercase c equals 12, and the lowercase b equals 9. And we're going to find the missing side and the angles. So solve the triangle. I'm going to draw a diagram first. So this is the A, B, C. And I know that angle C is going to be 85 degrees. The side opposite from it is 12. And the side opposite from B is 9. And then we can find this angle B first using law of sine. So we get sine B over B equals sine C over C, lowercase c. And the angle C is 85 degrees, lowercase c is 12. Oh, let me just leave it the way it is. So I get sine B over lowercase b is 9 equals sine C sine 85 degrees over lowercase c 12. So I'm going to multiply by 9 on both sides. We get sine B equals 9 over 12 sine 85 degrees. And I'm going to take inverse sine on both sides. So B equals inverse sine of 3 over 12 sine, 3 over 4 divided by 3 from 9 and 12. So sine 85 degrees. If we put this into the calculator is going to give us 48.3 degrees. Okay, that's what the calculator tells us, nothing wrong there. But remember, we have to find the second angle, right? So the calculator gives us one angle, but we have to find the sort of the symmetric angle, because on the unit circle, we get this B is 48 degrees, 0.3, 48.3 degrees, but there's a second angle corresponding to it on the left side in the second quadrant. So we have to find that angle. So that's going to be 180 degrees minus 48.3 degrees. So that's going to be 131.7 degrees. Okay, is this like the previous example that we have to work with both angles to get two triangles? Well, maybe. Let's suppose that's the case. So let's find out the angle A, because we know C is 85, B have two different possible values. And what about angle A? So angle A is going to be 180 degrees minus B, 48.3 minus angle C, 85. And that's going to give us 46.7 degrees. That's fine for an angle inside a triangle. Or if we choose the different angle B, 131 degrees, so we get A equals 180 degrees minus 131.7 minus 85 degrees angle C. And we end up to be negative. Oops, let me move this. So in the second triangle case, we end up with negative 36.7 degrees. Now, you know that in a triangle, the angle has to be from 0 to 180 degrees. you cannot have a negative angle. So this is the problem. So not a possible angle. So we don't have to consider the second angle for B because it doesn't, the second triangle doesn't exist, only one triangle. So that's how I solve those problems. Assuming that it's no problem, we can just solve it the way we want. If we get two different angles by taking the inverse sine on both sides, we're just going to continue with two triangles. But if one of them doesn't work eventually, when we find the third angle, so we just drop it. So now we just have one triangle, the one on the left, with B being 48.3 degrees, A being 46.7, and we already have C being 85. All we find next is going to be the missing side, A. Then we're going to use sine A over A equals sine B over B, or sine C over C. So A we know, so we get sine 46.7 over side A is equal to sine B. So that's going to be sine 48.3 divided by lowercase b is 9. And we should be able to solve for lowercase a. So cross multiply. So we get 9 times sine 46.7 equals a times sine 48.3 divided by sine 48.3. So we get a equals 9 sine 46.7 over sine 48.3. So that's going to be 8.8 if we put in the calculator. And you can tell it's correct because the two angles are very close. One is 46 degrees, one is 48 degrees. So the length should be similar. Any questions on this? All right. If you don't have questions, let me go through another example with you. I have two more, but I'm going to save the second example for next time. So the next example says, so in a triangle, we are given that one angle is 50 degrees, and the side opposite from this angle is 4. So that's the length. And another side is 10. So if I graph it, so suppose this is my triangle ABC. Let's see, A is 50 degrees, and then we know the side opposite from A is going to be 4. And there's another side that's going to be 10. It doesn't matter. I could say, okay, AC equals 10 or AB equals 10. Doesn't really matter which side. It's going to be angle side either way. Okay, so let's solve for the triangle here. So solve for the triangle. So here in the setup I have, so I have 10 is opposite from angle C, so we can find it first. So let's just set it up. So we have sine A over A equals sine C over C, lowercase c. So we have sine A is 50, so sine 50 degrees over the side A is 4 equals sine C divided by C is lowercase c is 10. So I'm going to multiply by 10 on both sides. So I get 10 sine 50 degrees over 4 is equal to sine C. And if we put this into the calculator, suppose I'm just, wanting to figure out what that is. If we put that into the calculator, so we get this value equals sine C. So we get sine C is equal to 1.915. Okay, so let me know what you think. So if you see that sine C equals 1.915, that should be something jumping into your mind. It's like, oh, that doesn't look right. Because if you remember for sine function or unit circle, so the maximum sine is going to be 1. The minimum sine is -1. Same thing for sine function going like this. So the maximum sine is 1, the minimum sine is -1. But all of a sudden here we have a sine that's going to be more than 1. So that's the problem, right? Because we cannot have, normally we cannot have a sine ratio that's more than 1. So this should be a problem. So since sine theta is always going to be from 1 to -1, so that's no solution. No solution to sine C equals 1.915. So in this case, we don't have any triangles. Therefore, no triangles exist here. So the problem, they just give you a problem, right? But it's perfectly normal when you try to solve it and then you end up finding like no solution. So that's this case. It's impossible to have a triangle in this way. What happened is that if we go back to the diagram here, the actual diagram, obviously, let's just say this is 10, and this is the angle 50 degrees. I don't know how long this side is, but whatever the full is, so let's say this is the full. The full is never going to be able to reach the 10. It's not going to be able to reach. So if we extend this, so the full here, it's just not going to be able to reach to that end of that 10 unit. It's not long enough to make a triangle. All right, does this make sense? So again, like, problem like this, you take what's given and you try to solve it, assuming that everything works out well. And until something falls apart, then you look back, it's like, oh, okay, that makes sense because it doesn't make a triangle. But most importantly, I want you to pay attention to the case that you might have two triangles. That's the case that when you have angle, side, that's given. Which when you solve for one of the angle, the first angle using inverse sine, don't forget to find a second corresponding angle, a second angle there, and then use both angles until you reach a problem. But sometimes both angles work fine. Okay, any questions on this? I know we did quite a lot today. It's a lot of information. Just do your best. Some of it might be a review, some of it might be new. The homework, again, take a look at the homework if you haven't. It's due Friday. I know I still owe you a quiz 4 and exam 3. I was going to work on them today, but something got in the way and I wasn't able to finish it. But I'll try to get them to you as soon as possible. I have to finish grading before Friday anyway. All right. So if you don't have any questions, I'll see you tomorrow. Take care, everyone.
Thank you.
Okay. Yep. Goodbye.